In the last session, we have discussed the RC circuit with current source, in which this resistance is not there. Now, in this continuation, we have added this resistor. Okay, and we will observe the behavior of the circuit, and we try to find V out. We'll try to find V out and time constant tau, and we will plot VR, and let's say this as V dash, and we will plot V dash also, and we will try to plot the current through capacitor, which can be IC. Okay, we will plot IC also, and if you want we can plot this IR also. Okay, IR also we can plot. Let's say this is IR. Okay, or yeah, IR. Yeah, all these things we will try to plot, and this analysis is kind of important for interviews. Okay, let's start at t is equal to 0 plus. T is equal to 0 plus, how the circuit will behave. First, the capacitor initial voltage is Vc is equal to 0 volt. Okay, so it will be act as, capacitor will act as, at time t is equal to 0, it will act as short circuit. Since it is having 0 volt, it will act as a short circuit. Okay, now if we redraw the circuit, it's always advisable to redraw the circuit when we are analyzing, so it will be a good habit to follow in interviews also. So the capacitor, and it is short circuit, right? So since it is short circuit, no need of resistor. Short circuit which is parallel with the resistor will give the short circuit only. So here we have the current source, which is of I is equal to 1 ampere, and this, okay, for simplicity let's write the values of R is equal to 1 ohms and capacitor is equal to 1 farad. Okay, this is R, and now what is the value of I flowing here? It will be 1 ampere obviously. So the voltage across the resistor will be VR is equal to 1 volt. Okay, that's done. Now next, V dash. V dash will be 0 volt, right? And next, because it is short circuit, okay, V dash means the voltage across the capacitor parallel to resistor. This parallel combination resistor voltage is the V dash, so it will be 0 volt. And next, IC, current flowing through the capacitor. IC at 0 plus is completely current is flowing through IC only. This is capacitor, so it completely going here only, so it will be 1 ampere. And IR at 0 plus, it will be 0 ampere, because no current is flowing to that part, because this capacitor is offering very less resistance. And what else we need to plot? Yeah, V out. So we know that V out of 0 plus, right? V out is equal to VR plus V dash, so it will be 1 volt, addition of this volt and this volt. This is the analysis at time t is equal to 0 plus. Now let's see at time t is equal to, let's see with some other color, maybe with orange. Yeah, at t is equal to infinite, how the circuit will look like. First we will draw the circuit at t is equal to infinite. At t is equal to infinite, capacitor will act as open circuit. So let's redraw the circuit. This is open circuited, and this is the current 1 ampere. So the complete 1 ampere current will now flow through this path. Since the capacitor is open circuited, means it is offering high resistance, so there will be no current flowing through it. That also means it is completely charged. So the voltage drop across this R will be 1 volt again, and this R will be 1 volt. If you see here, another thing, yeah, we will try to write everything. First VR will be 1 volt, and V dash will be, V dash at infinity will be again 1 volt, and current flowing through a capacitor will be 0 ampere since it is open circuited, and current flowing through the resistor will be also 1 ampere, and V out will be equal to sum of both of them, it will be 2 volt. Now let's draw the graphs one by one. Now first graph can be V dash. Next, you also try to draw the graph and cross verify that. Next, this is V out. Next, IC, and next IR. So V dash will be initially the voltage across V dash will be 0, and it then keep on increasing and reach the value of 1. 1 volt it reached. When it comes to VR, it is constant voltage, since constant current is always flowing here, 1 ampere current. So it will be 1 volt constantly. So V out is the summation of both of them. It started from 1 volt and it gradually exponentially reached to 2 volt. When it comes to IC, the current flowing through IC means capacitor will be initially totally 1 ampere current is flowing, and finally gradually reduced and reached to 0 ampere. And when it comes to IR, it started with 0, means no current is flowing earlier, and it gradually exponentially increased to 1 ampere. This is how the graph looks like.